Okay. So good morning and GMs and all the things. Who am I? I'm David. I'm the CTO of Finium. And Finium is a full stack dev shop working in Portugal, focusing on the Starknet ecosystem. And we have people around here that you can identify us with our symbol. If you want to follow us, there's our links and things like that. So, first things first. Survival guide for a workshop. Share knowledge, don't be afraid to ask questions. If I didn't explain anything first the right time, don't be afraid to stop me, ask me questions. We're going to have a coffee break. Yeah.
I don't think the mic is working.
The mic is not supposed to be working, it's just for the recording. So maybe I'll speak a bit louder, it's fine. FYI, this is being recorded for waiter consumption, and don't be afraid to stop me anytime. Okay, hopefully you followed all these steps, but basically to work with Cairo, you need to install Rust, you need to install the Cairo compiler, you need to install the Starknet CLI, all the documentations are here. We have a repo for the workshop that we are going to use to make some tests and some exercises. And if everything is properly set up, running make test on the Cairo workshop repo should be showing one test passing. Okay, so what is Cairo? Cairo is the first Turing-complete language for creating provable programs for general computation. Nice definition. I took this from the documentation from Starknet. What does this mean in practice? In practice means that a provable program is a program that you can prove mathematically that the computation was executed and the result wasn't tampered. So let's say that I have some program that I want to run, and I don't have the architecture, I don't have the infrastructure needed to run my program. I want to give my third-party competitor my program, and they want to run them on that machine. But I want to be sure that the computation was successful and it wasn't tampered with, and they didn't give me wrong information, or they didn't change the output of my program. Yeah, basically it. So with Cairo, we can do it. And there was an old version of Cairo called Cairo 0. And Cairo 0 had a problem, which was computation in Cairo 0 could be a true, a false, or a failure. And the failure means that you can't prove that a run was executed correctly. So you don't have an output, a true or a false. You have a failure. You don't know exactly what happened to the program. And that meant that computation wasn't mathematically proven to be correct. With Cairo 1, we now have the possibility to do that with the introduction of an intermediate representation system called Sierra between Cairo and the assembly code that's going to be running. And Sierra does what it says here. It ensures that the Cairo run will never fail and can only result in a true or a false. And this means that every Cairo program can be proven mathematically, and it's either true or a false. So basically, these are the steps. We rewrite our programs in Cairo 1. There's a compilation step to Sierra. That compilation step then is the input to another compilation step to Cairo assembly. And Cairo assembly is what's being run on the Cairo Starknet ecosystem. We don't need to look into Sierra or Cairo assembly. We are just going to be looking at Cairo 1 and writing Cairo 1. So how do we do things in Cairo 1? Let's start at the beginning. Let's define some variables. This is how you define a variable. You use the let keyword, followed by a variable name and a value. And since Cairo takes a lot of inspiration from Rust, there's also a mute keyword. And this mute keyword means that a variable, the value of a variable can be changed. So if we only define let a equal 1, if later on we try to reassign the value a to another value, the compiler will say, no, you can't do it, because the variable needs to be explicitly told to be mutable. Also, Cairo has basic types and is a typed language. And one of the first that you might see is the felt 252. Why felt 252? Basically, all the cryptographic math that works behind the scenes uses something called modulo operator, prime mathematics, that use a prime number to perform cyclic computations. And this is the largest prime that we can do in Cairo and we can use to make the computation work. It's a 252 because it's a number of the prime that represents it. We also have smaller types, 8 bits, 16 bits, 32 bits, 64, 128, and 256. There's also usize type, which is basically an alias for the U32. We have booleans, true or false. And we have options and results. And if you are familiar with Rust, this is basically the same thing that we have in Rust. We're going to see this in a bit more detail later, just to be aware. Now, we have variables. We have types. We can also have operators. We have the basic if-else operators. We have the match operator. We have loop. This is a new operator that was introduced to the language a couple of weeks ago. It's still very work in progress, but it's not a traditional loop in a sense it's a for each or if a for loop. It's literally one loop. And we also have mathematical operations, plus, minus, subtraction. Yeah.
What's the match?
What's the match? The match is used to do pattern matching, and we are also going to be looking at this in more detail later on. But basically, it's a way of setting or checking if a value matches a certain condition, and if it does, make some expression run. It's a bit more advanced than in if-else, and it's a bit less like a switch and case. We'll see it in a bit more detail. OK. So functions, pretty standard. We use the fn keyword. We use the name of the function that we want to declare, the arguments to go here, and we need to specify the type of that values. We specify a return type for the function. In this case, we are defining a sum function that gets an A and a B and returns the sum of those values. And we know that if they are FEL 252s, when we sum them up, we're also going to get a FEL 252. This is where you define the body of the function, pretty standard. And this is another thing that Cairo takes inspiration from Rust. The last expression in the function gets evaluated and gets returned. If you don't specify a return explicitly, and you don't have the semicolon here, this A plus B will be the return type of the function. But if we want to be explicit and we want to say this is the return type and we might want to break early or whatever, we can explicitly say return these values, and we need to end the line with semicolon. Because if we don't, this function will do nothing, basically. If we don't specify a return type, and if we don't have an explicit return, and we end a semicolon at the end of the last line, this function will simply take A, sums it up with 1, assigns it to B, and does nothing else. So this is one way of making side effects with functions. OK. So match operator. Basically, you have some value that you want to match with, and that value will be matched against the multiple patterns that are defined here in the body of the function, in the body of the block. If it matches with the pattern, then we run the expression on the right side. Simple as that. A more explicit example will be this. Let's say we have value A assigned to true. If we do match A, we know that A is true, so we'll get 1 back. This is a match operator. One thing to take in consideration, and this is why we should use matches, and one of the major benefits of using a match is that you can ignore all the rest of the expressions that you want. Let's say that we have an enum of red, green, and blue. We have our color, and we can match our color against. I only care about if the color is red. If the color is not red, I can specify an underscore here and say all the rest will be ignored and will be catched by the default expression. OK, yeah, I had an arrow pointing there. There's currently a limitation in Cairo which is you can only match numbers against 0. You can't match against 1, 2, 3, because there's a non-finite list of elements that you could possibly match against. So you can match against 0 or everything else. The match currently works this way. And yeah, first exercise. I'm not sure if you all have the working repo, but I'm going to show here what we'll need to be doing. So is this, let me make it a bit bigger. Should be fine. OK. So in the Cairo workshop repo, we have some files and we have some tests for the specific files. And if you take a look at the exercise1.cairo file, you can see 3 functions. And those functions are basically this. We return a 0, and a true, but the test, and the test is here. If we open the test, the tests are being ignored right now, so the tests are not running. We can delete the ignore lines here. And now if we try to run the tests with make test, this is going to fail. And for the first exercise, the idea is to change the functions in exercise 1 to make the tests pass. Any questions? No? OK.
What's the file?
The file is exercise1.cairo. And you need to go to exercise1_test, delete the ignore lines, so that you can run make test and have the test fail. Did you manage to make it run yet? No.
I have the repo, but I don't have the Cairo installed.
OK. Yeah, the Python 9, it's
annoying. Maybe is there any browser-based IDE that I can work on?
not for this, because you need to make run. You need to run things locally. We have the tests and all things, so it's not working.
Okay.
But maybe what we can do is we can make it interactive and we can solve the exercise altogether, because I think they still don't have it running, right? You are still struggling with installation, right?
Yeah.
OK.
I'm sorry.
No worries. I think what we are going to do is we are going to solve it here, and I'm going to ask for you to come up with solutions instead of trying to make install everything all at once. We are going to solve it here, and you'll tell me what to do, basically. The slides, not yet. I'm going to share the slides on Notion. test-wise are on Notion. Let's go back to this. Not public. No?
Instead of Finium here, you can choose
Anyone
with a link.
okay.
Yeah.
And just copy, or it should update automatically.
Yeah, it will update. Yeah, done. If you click done.
Wait. Yeah, viewers.
Yeah.
Okay. Okay. Can you check that you can see? Okay, cool. Okay, so let's solve this. Let me make this like this. Okay, and let's do one by one. Right now, everything is ignored, so all the tests are being ignored, and we don't want that. We want to remove the ignore here, and we want to make this test pass. So, not make build, make test. We can see here that this test is failing, right? And we know that this test is calling the function var in the exercise 1 module. And if we open this here, wait, okay. If we open the file here, we can see that the value of var currently being returned is a 0. And if we go back to the test, we see that we are expecting to have the value 42. So what's one solution for this?
Just write 42 instead of 0.
Okay. This is just the basic first test, so you can understand how things are working. So we have a function here. The function has a return. We don't have a semicolon, so the value gets returned automatically. When we call this in the test, we can use this syntax here to call a function. So now if we do make test, we can see that our test is passing. Everything's OK. Now, let's go to the second one. And we have here test sum, and it's also being ignored. If we remove this, and if we go back to here, sum, I know that the name is not ideal. The function doesn't sum anything. But we have a value that's being inputted to the function, and the test expects to have some value returned. So the expected value should be something like this, and the output of this function should match this. So if we do make test, the test will fail, because the sum function is returning a 0, and the test is not expecting a 0. What should we do here to make the test pass?
Can we see the other file?
Yeah, it's here, it's this. So the function is expecting to receive an input, in this case is a 0. And the output of the function should match 42 minus the input.
21.
You can try 21. No, still fails. It's also 42. Yeah. There's basically two solutions for this. We can change the function here to return always 42, because the test is expecting to have 42 minus the input, and the input is 0. So the test is always expecting to receive 42. Or we can also make the function have the 42 minus the input and should match the expected value. Okay, make test again. Everything's OK. Now let's move on. We have another test here. Test if a value is even, and at the same time test if a value is odd. The same function here, test even. I know it's not the best name again, but we have two tests. One should return true if the value is even, and the other should return false if the value is not even. If we go back to here, we can see that the function even receives a value. This is a 8-bit value, and returns a boolean. In this case, it's always returning true, but we want to check if the value is odd or not. How can we do it?
0, 2, 4, just give an even number, right?
No, you need to return a boolean. You can't return a number here, because the boolean means we need to return a true or a false. And if we can check the test, yeah, basically modulo 2. The function here is expecting to have true or false, and the same function should return a true or a false based on the input. So what we can do is here, we can do if value modulo 2 equals 0, we can say it's a true, else we can say it's a false. Interesting thing here. A 0 and any number that you define in a Cairo program is by default a felt 252. And you can do comparison operations with felt 252s. You need to convert this into a U8 or to any other type. And the way we do it is just underscore and the type of the value that we want to pass in next to it. So this, and I need to remove the ignores here. Make test. Everything's green, everything's okay. Okay, cool. So basic functions, basic assignments of values. We can see already some operations. We do an if, module operation, you do a comparison. Pretty standard stuff. Okay, let's go back here. Yeah, this was the slide for the solutions. Okay, so recursion. Have you ever heard of recursion? Do you know how to make a recursive function? Basically, this happens all the time, but I'm going to explain it in the simple terms. A recursive function is a function where you always check against the base case, and if that base case is true, then you stop the execution. Otherwise, you call the function again with new values to the input of the function. So you can end up in an infinite loop here if you mess up your base case, or it might simply take a long time to execute until you reach the final conclusion. So let's say we want to have a function that sums all the numbers between 1 and 5. And we are going to use recursion for it, just because we are talking about recursion. We could define a function like this. So function, a sum of ranges. We start with a value, and we end in the other end. And if we check the base case here, when we match the start to the end, we say, OK, let's stop the recursion. Let's return a value. We don't want to recurse anymore. If the start and the end are different, and in the first case and in all the other four cases will also be different, we are going to say, OK, I want to sum this number with the recursion function, with a recursive call of the function with +1. So we are always incrementing towards the end of the range. And this will basically be decremented or will be decompiled into something like this. We start with a sum range 1 to 5, and then we have a 1 plus the sum range 2 to 5, all the way until we reach the base case, and then all the functions finalize and make the sum back, and we have 15. OK, so exercise 2 would be to write a Fibonacci function using recursion. Just a quick introduction to Fibonacci sequence and the Fibonacci function, if people are not aware. There's a sequence of numbers called the Fibonacci sequence, which starts with a 0 and a 1. And the way you get the next number is to simply sum the last two numbers. So Fib of 2 will be 0 plus 1, and 0 plus 1 is 1. Fib of 3 will be 2, which is 1 plus 1. 3 plus 2, 5, 5 plus 8, whatever. So this is basically a Fibonacci function. And we also have the same thing. We also have some exercises here on the exercise to Cairo file. By the way, this needs to happen right now because the compiler still can't estimate the amount of gas it needs to use. So this needs to happen. But basically, right now, the function is always returning a 0, and we want to change it. We also have a test here. Okay. Let's start here. If I do this, might be better. This way you can see the code and the test and the execution here. So this test will now fail because I have missing curly braces. Mm-hmm. Okay. So, any ideas how we can write a Fibonacci function? Any suggestions? Go ahead. Base case first, okay.
0 or 1, you return 1.
Okay. So let's see if value equals 0 or if value equals 1. We return 1. Okay. And then?
And the alternative case is return the Fibonacci of value minus 2 plus Fibonacci of value minus 2.
Okay. No, it's a different way of doing it. I have a solution here. It's not that way. It might work as well. It should work. So value minus 2, right? The first.
Yeah.
And then
Minus 1.
Fibonacci of value minus 1. Okay, so let me uncomment this. Yeah, I need to do this here. No, this works. Maybe it doesn't. I'm going to do it this way. Okay, it says here it failed, and it failed with not the expected value. So something, yeah, you can see here, basically, I didn't explain this, the test, and if I make this like this, the way we do tests is we call a function and we compare it with the expected value. Otherwise, we get the message in the second parameter of the assert function. So what this meant is we inputted 1, we expected to be 1, the expected value, but it wasn't. So something in the implementation is not right. If I go back here,
Maybe we can do return value plus Fibonacci value minus 1.
Basically, there's something here like the Fibonacci of n is the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So this is the expression to calculate the Fibonacci number. So this part here is correct. So Fibonacci minus 2 plus Fibonacci minus 1, it's the same thing. So the problem is here, it's a 0. Yeah. Fibonacci of 0 is 0, Fibonacci of 1 is 1. And I think this should be working. Yeah. The base case was wrong, so it happens. And I'm going to show a different way of doing it. I need to stash this first. If we go back here, basically, if we go back here, we can see that we call it a function, right? We start with some range, and then we keep an operation pending until all the recursion is finalized. So we have 1 plus the sum range, and then we have 1 plus the next function, and so on, so on, so on. And this gets very intensive very fast because we are simply calling new functions with new values. And there's something called tail optimization in recursion, where you can simply move the recursion out of the computation and be the recursion, the last step that you do when you make a recursion call. Because in this case, we are always doing a recursion, and when we stop with recursion, then we still need to sum everything back. And if we do tail recursion, and we have a solution here, you simply change the way you do recursion. And let's say we wanted to do Fibonacci again, we pass in the value. But instead of, like we have here, recursing, that's a word, instead of always recursing and then making the sum after the recursion, what we do is we go in the same directions, in both directions at the same time. So we are summing the values as we go, like here, but we are also recursing through the function. So we know that the first value of Fibonacci is a 0, and the second one is a 1, so we can define a new function just to have it stored somewhere. And when we do recursion, we say, okay, I know the value that I want, minus 1 should stop here, but if it doesn't, I'm going to make a sum between the last two known values. And we know that the first two is 0 and 1, so we simply are saying, okay, I know the beginning of the sequence, right here. I know 0 and 1, and if I want to calculate it till 5, I can go, okay, I know 0 and 1. Fibonacci of 5 is the same as Fibonacci of 4. And when we do this step, we already make the sum to the 1. And we change the values here to be Fibonacci of 2 is now the Fibonacci of 1, and the sum is the Fibonacci of 2. So we keep moving forward and recursing. And when we are finally done with recursion, when we hit one of the base cases, the computation is already done. Let me know if this made any sense. I'm not sure if it did. Huh? It's not much more complex. It's basically a way of thinking of recursion. Instead of saying, oh, okay, I'm going to, like we have here, I'm going to call for Fibonacci of a number. I'm going to do Fibonacci plus another recursive call. Instead of doing this, we simply abstracted this sum function into the inside of the function. So that's basically it. And this happens, and Cairo uses recursion a lot because we deal with big numbers. And if we try to do it this way, where we keep waiting for the result of the recursion, we'll quickly run out of memory and problems will happen. So tail recursion is one important step to have in mind. Let me go back to the main thing. Okay. Let me check the time. Okay. Let's start into a bit more complex things. So basically everyone should be aware of this, but this is a color wheel. It's a way of representing colors in computer and outside of computer programs. We can have RGB, we can have CMYK, we can have multiple combinations of colors, and we can have basically a representation of a color module. And if we wanted to represent this in a Cairo program, we could use a struct, and that struct will contain the values for a specific color. For RGB, we will have one value for red, one value for green, one value for blue, like this. So we can define a struct using a keyword struct. We give a name, and we specify the elements that we want that struct to have. In this case, we only have 3 values. This is basically a way to aggregate information into one box, and you can say, instead of having 3 random values or in 3 different variables, we have one variable that contains the values inside. Any questions? No? Okay. We can do the same thing for the CMYK color module. Instead of having red, green, blue, we have cyan, magenta, yellow, black. We can basically mix and match the number of colors and the amount of colors to get the same output. Yeah, we briefly saw enums back, but enums are one way of also having specific information. The difference between a struct and an enum is basically an enum can only have one instance at a time. We can have a colors black and colors gray. We define a color, and that color will be constant through the program. Okay, now traits. I'm not sure if everyone is familiar with Rust. Have you ever looked into Rust? No? No one? Okay. I'm going to explain this like if it was interfaces in C++ or traditional Java programming. A trait is basically one way to define functions that we want to enforce the compiler, that implementations of those traits have to follow. So a trait is basically one way of defining an interface. It's not technically an interface, but it's basically an interface. You can define the signature of the function and the return type and the input values and so on. And if you wanted to implement something that uses that trait, then we'll define the output of the function, the content of the function. And this is basically the syntax that we use for traits. We have an impl to define an implementation. We give it a name. We say the name of the traits, and then we define the functions. One important thing to note here, all the functions that we define in a trait need to be implemented by the implementation. We can't have 5 functions here and only implement 2 of them. The compiler will warn us and will give an error saying, you have to implement all the functions, otherwise it will not work. And one way of calling an implementation or a trait implementation is using this syntax with the name of the implementation, followed by 2 colons, and then the name of the function that we want to call. That's pretty much it. Any questions? Okay, so can you implement more than one? Yeah, you can have multiple implementations of the same trait. I think we have, I'm not sure if I have an example here, but basically you can have as many implementations that you want of a trait. You just need to give it different names. The names can't match, can't collide. Yeah, generics. So generics is basically one way of abstracting types, and instead of defining one type or multiple types explicit, we say that a function or a struct receives a generic type, and it can be any type. Here we have 2 queues, one for RGB and one for CMYK, and the respective implementations like we have here. So nothing pretty weird, but we have to specify that this queue is for RGB, and we have to specify that this queue is for CMYK. And the queue is basically a data structure that we can use any type and any value that we want. So we can use a generic to specify the generic type of that queue. It doesn't matter what the queue contains. The function should work the same. The input is not, the content is not relevant. So the queue here, we define it with a T type. It's basically a convention to use types, to use generics. And instead of having an elements array which only accepts RGBs, we have an elements array that accepts any type. We can use it like this. When we are instantiating our queue, we say, OK, now I need to know that this queue contains this specific type. So we pass the type of RGB, but the queue is generic and accepts any types. So we can reuse the same queue to use CMYK or RGB. Yeah, and the enqueue function works the same way in both implementations. It's the same implementation, it's a generic type. Any questions? Cool. OK, so we can also use generics. Yep.
I wanted to implement a queue that could take the two types of, so RGB and CMYK. How could I do that? Because the queue still only accepts one type, right? So if I want to have a queue with both types, how would I implement generics for that?
You can implement a super type that contains both types. I'm not sure if we can use unions here yet, like we do in TypeScript. I'm not sure if this is possible. I'll have to double check. But yeah, you can define a type that contains RGB and CMYK and use that type instead. You don't need to specify the type explicit, just can be any type. Yeah, but I'll double check the union thing. I think I saw something in the compiler, but I'm not sure. Yeah, traits. Traits can also be generics. So basically, we have a color module trait that can accept any color, and we can return any type of color that we input to the trait. We can define 4 functions here: new, cyan, magenta, yellow, and these functions should return the specific type that we want to correspond to that color. So if we have an RGB struct here, the cyan should be the RGB representation of the color cyan. But if you have a CMYK, it should be the CMYK representation of the color cyan. Basically this. When we define the implementation, we pass in the type, we specify the output type, and we define the output of those functions. Same thing for CMYK. Yeah. So let's say that we wanted to check if a function, that's why we wanted to add a function that checks if a color is red. And this doesn't matter if it's a RGB struct or a CMYK struct. It simply wants to make the checks. In this case, since we are implementing for one specific type, we have to be explicit. And we simply can add a T here, because we don't know if the struct that we are receiving contains the element red. Because if it's a CMYK, red will not be present. It will be cyan or magenta. So you can have a generic type, a generic trait definition, but implementation needs to be explicit. OK, so another exercise. And this is basically using traits and implementations like we've been seeing so far. So let me go back here. Oops, I closed this. If I do, OK. So we have a shape trait here that accepts any shape. And we have 2 functions defined on that trait, an area function and the perimeter function. And the self keyword here means that it's the trait type implicit. You don't need to say when you define a function for a generic or when you define a function for a trait, you can use the self keyword to refer to its type implicitly, like we saw here. Self here, and then I can use self to access the red value of the RGB struct. So this is a way of accessing the type. Then we have a struct triangle and a struct circle that contains the radius and contains the base, the height, the B and C for a triangle. The exercise is to implement the shape trait for the triangle and for the circle. And if I open the test here, OK, let's do it one by one. Let's start with the triangle. We can define a triangle this way. This is basically the way of instantiating structs. You define the name of the struct, and then the types, the elements of the struct, and you create a struct. And then we call the function area and call the function perimeter. And these functions are not implemented because we don't have implementations for it. So how do we implement things here? Suggestions? No suggestions? Okay. Let's go back here. So if we look at this, we have a trait, and we have the function that we want to implement, and we can create implementations for that trait. So basically, this is the syntax that we want to use. We can go here, and we say, OK, I want to implement a triangle. If I know how to type, a triangle implementation of shape, like we have here. But since shape accepts a generic type, we need to be explicit, and we need to say, this is a triangle. And then we want to implement function area, function perimeter. So we copy this back here. And now we need to make some math here. How do we calculate the area of a triangle? Basic math. Base times height. Now I'm not sure. I think it's this.
I don't think it makes a difference.
Okay. Yeah. Okay. So this and this. Okay. And the perimeter of a triangle.
Just sum all the sides. So if it's the size of the sides are all the same, it's just the base times 3.
Yeah. I added here the B and C because this is the other sides. So base is the base of a triangle, height is the height, but then B and C are the all other sides. Just in case they are not the same size, we can do here. So base is one side, then B is another side, and C is another side. Cool. So if we do make test here, things are broken. No, because this here needs to be a specific type. This needs to be triangle, and this needs to be triangle. Okay, and we also need to use the self keyword to access the values of the struct here. Otherwise, we'll get an error. Okay, if we go back to the test, and this is uncomment. We have an error here.
Is it missing a semicolon?
Not a semicolon, it's missing a specific type. Because if we use a 2 here, this 2 will be a felt 252 by default.
U64?
Yeah, so underscore U64. So if this, yeah. Okay. Okay, no, it's ignored. Why is it ignored? Shouldn't be. Okay, I didn't save the file. So now we have tests passing. Then we're still missing the implementation for the circle. And I'm going to simply copy this because it's the same thing. And I'm going to do it here. So we have a circle. How do we calculate the area of a circle? And we need to change this to circle. area of a circle. And
We also need to change the name of the implementation, right?
we also need to change the name of implementation. Nice catch. So area should be
The radius
the radius.
by to the power of 2.
Yeah. Let's assume pi is 3, just because we don't want to deal with decimal values. So radius squared times pi times 3 in this case. And the perimeter,
2 times y times radius, I think.
2 times pi times radius.
Yeah. The 2 needs to be U64, right?
Nice catch.
And the 3 as well.
The true and the 3. Okay, make test, and everything is breaking because I forgot here the here. This is not a triangle, this is a circle. Okay, everything is green. Let's move on to ownership, borrowing, references, and snapshots. Okay, so in Rust, there's a concept called borrow checker, and that concept basically prevents us to have dangling points of memory. And the way it does is by keeping a reference to every value and every function call. And Cairo, since it's a lot inspired by Rust, it also uses the same mechanism. So when we define a function, or when we define a value, let's x equals y here, and if we call a function and we get the value of x to that function, the ownership of the variable is going to be transferred to the function foo in this case. And this is known as a move. So you need to be taking this into consideration. When you pass something to a function, you are passing the ownership of that value to that function. If you don't want to do it, you can use a reference, and instead of using the value, you pass a pointer to it. And the way Cairo deals with this is this way. So we have a struct RGB, the same, and we created a new color. And when we pass the value, when we pass the color variable to a function by value, the compiler in this case will give an error in this line saying that we can't use the color.red here because color is no longer owned by the main function. So since we pass it to the function passed by value, we lost the ownership. And the compiler will warn us about it. If we want to keep ownership in the main function, and we want to pass the function value to the pass by ref function, we can use a ref keyword here, and this creates a reference pointer to the value, to the variable, and then we can access it after we pass it to a function. So this will work because we keep the ownership back. We get the ownership back on the main function. Is this clear? This is confusing, I know. Okay. I'll do it again. We create a function color here, a variable here, color. And we say that this color variable is going to be used in a function, in this case, passed by value. When we pass the color variable to this function, if we try to access it after the function call, the compiler will say, you can't do it because you pass the ownership of the function, of the value to the function.
Why does that happen? Generally, it's not a function of operating the copy, right? So
Yeah, this is a Rust thing, and since it's a Rust thing, it's also a Cairo thing, so that you don't have the dangling pointers that you don't have lost memory. And the way they keep track of memory is by doing this system. Every single value is owned at the most by one function, by one entity, whatever you want to call it. And when you pass it to another function, you either create a reference to it, and you pass it by a reference by specifying the ref here, or you lose the ownership. So this is a way of preventing some types of bugs that are common. And this case, since we are trying to do color.read after we lost the ownership, the compiler will give an error and say, you can't do it. You can do it if you use a reference, but then the ownership remains in the main function. The main function keeps control of the color ownership. It's just using the reference to pass it to the function. Yeah, if you no, you can use it, and there might be situations where you want to have a function affect the value of your variable. Let's say pass by ref here would add some color to the RGB struct. That will happen, and that's fine. That's no problem. Because the ownership then gets returned back. So the function pass by ref doesn't keep the ownership of the value when the function executes. After the function execution, the ownership gets sent back. Because there might be a situation where if you didn't pass it by reference, let's say we do it this way, and the pass by value function free the memory, drop the value, delete it some way, then you will be trying to access something that doesn't exist. And this is a bug. This can't happen. So this is how they decided to deal with it. And this is one way of passing values and keeping the ownership. Another way is to use something called snapshots. And you can identify snapshots by looking at the sign here. So this function here, length array, receives a value, and it's the type snapshot array of usize. And in this case, this is a manufactured function. I'm purposely creating a new array and changing the value of the array. So in here, I create a value, and I added the value 1. But then I call the function that I expected to simply give me back the size of the array. And that function, instead of giving me the size, is changing the actual array. With a snapshot, this is prevented. You can change snapshots. The compiler will give an error saying you can't assign something to a immutable variable. You can't change memory because the snapshot is read-only information. You can access it, and the way you access it is by doing the star sign here. So we receive a snapshot, and we can get the value in the function, but we can change the value. This is important. Any questions? No, it's fine. Okay. Yeah, I think you already saw derive here, for example, derive copy, derive copy here again. This is something called macros, and this is a way of making some functionality, to add some functionality to a specific struct or specific function or whatever. In this case, the derive macro is being used to automatically define copy and drop functionalities to this struct. What do I mean by this? The derive is nothing more than adding this line of code to your output code, to your compiled code. And when you get the output, your implementation will look something like this. You don't need to look at this implementation, just the way it works behind the scenes is that the derive copy and derive drop get translated into implementations of specific implementations of a copy and a drop function. And this is useful because you can define, or you can use a derive copy to make something copyable, clonable. So you can create copies of it. So if we could create here a color and we pass it by value, now the compiler will not give an error because instead of passing the value to that function, we are creating a clone of it and we pass a new value to that function. So this is different from the example before here, where in here, we would pass the color variable, the color value, to this function. And the compiler says you can't do it. But if we derive a copy in the struct, we create a copy of the value, and we can do it this way. Yeah, this is basically very C++ inspired. So copy clones, all those things. Okay, so ownership and all of those things that we just saw. So this is the one exercise, and this code is not compiling. And I have some exercises here. I think I can do it like this. I just need to make it show it's not compiling. Okay, so this is the same code. The code that's in the slides is the same code as is here. And if we try to compile this, we say we have an error, and it's pointing to array here, and array must be a mutable variable. What's happening here? We are creating an array, and then we are calling a function that gets that array value. And then we return a value back, and we create a new array. So what's happening here is that line 14, so line 14, if I'm saying this right, no, this is wrong. Should be, yeah, it's fine. Line 14 or 15 or 12, all those lines here are the problem, because we defined an array here, and then we pass it to this function, and then we are trying to change it. And we can change it if we don't have a variable mutable. If we don't define that this variable is mutable, we can't make changes to the variable. So by adding this keyword here, now we can do changes to the value here. And this code is fine and is not going to compile, not going to give an error, because we are not trying to access it in here. We are not trying to do something with the array 0 after we pass it to the function. So if we try to make this again, we also have to specify in the function that this receives a mutable variable. So we need to define it as a mutable, and we need to define the signature as it receives a mutable variable. So now should be fine. Yeah, it's compiling. So let's see another one. And it's basically this.
Since we didn't use the variable afterwards, do we really need to put the mute in array 0?
Here? Yeah, you need it. You need it because you are trying to make changes to the value here.
Yeah, but I'm passing by the value, right? So I'm passing the ownership to the other function, and I'm saying that the argument is mutable.
Yeah.
So should it just be mutable?
But if you don't define it as mutable, you can't make a change. If I make this here, okay, yeah. You need to define the value as mutable. When you pass it by value, you can define it as mutable so that you can...
Even if it's not mutable in the main,
yeah.
since I pass it by value to the field R, then it's mutable.
Yeah, exactly.
And the other way around, so if I just put the mute like that, then
Here?
it doesn't work because I'm passing by value and the argument is not mutable, so it fails.
Yeah, that's it. Basically, if you are going to make changes to a variable, you should always, because it's for the compiler, but it's also for the developer, so it's easier to see, okay, I'm getting a mutable value here, but I also define this as mutable, so I know that this is supposed to be mutable. I'm not trying to make some side effects happen here. This function is mutable, or this value is mutable, and this function receives a mutable value. But it's true. We don't need it here, because we are not trying to do anything. Yeah. If we do something like this, this will break. Yeah. This will break because you are trying to do something to a function, to a value that is not mutable. If we define it as mutable here, it will still fail because you are trying to access it after you pass the ownership to the function. But yeah, the same concept. So we were here. This code doesn't compile. And if we do here, need to uncomment this. It's not compiling because it says the variable was previously moved. So when we are trying to do something with this here, these order operations doesn't work. So we need to rearrange these lines to make it work. And let's go line by line. We are defining a new value A, which is an array. And then we are defining a value B that receives the value A, and we pass it by value. The functions here are just to simplify, to show what's happening. They don't matter the implementation, just the signatures. So we just need to change the orders of these operations here. We created the value A, we created the value B by passing the value A to it. Then we try to pass by reference the reference of a value B. Then we try to do it again with value A. And finally, we try to do a snapshot of A. And this doesn't work. And if I make this go that way, you can see maybe this way. Okay. Error on line 4. Variable was previously moved. On line 4. Shouldn't be on line 4, should be on line 5. Doesn't matter. We need to change the way of this here. Any suggestions?
On line 4, the ownership goes to, I don't know if it's there. Line 5 cannot do it because ownership is, no, line 5 blocks the ownership.
Line 5 loses the ownership. Let me remove the relative lines so that you can see the numbers that don't change right now. Okay. So we create a value here, right? This is fine. Then we pass it to a different function, and we assign it to a value B. Then we try to use it again on line 7 and line 8. And we know that this doesn't work because we already passed the ownership here, and we lost the ownership. So the main function no longer controls A. So first things first, should probably move this before we define the value B, right? So if we try to make it, it works. Simple as that. We can do anything we want with the value A. We can pass it by reference, we can pass it by snapshot. The moment we pass it by value, we lost the ownership of it, so we can no longer use it. So we couldn't do this, for example, because A is no longer controlled by main. Yeah, it doesn't matter if it's by reference or by snapshot first. It doesn't really matter, because both things work.
Just maybe to make it clear, the function name doesn't matter. What matters is the keyword inside the parentheses. When we say pass by snapshot, that could be like random function name, but because we are using the @ sign and the ref,
Yep.
that means that we are using like a snapshot and a reference. That pass by value, if it was just random function, because we are not using any keyword, it means that we are passing the value to the other function.
Yeah, the names of the functions are just to help visualize what's happening with the memory. It might be confusing, but could be any function here. It doesn't need to be, those specific names of the functions don't matter anything. Just the inputs here. We know that this receives a mutable reference. We know that this receives a reference. We know that this receives a snapshot. So it doesn't really matter. Yeah, I think we have one last one, which is this. So if I go here, no, not this. Okay, so same thing. We have an error here. cannot assign to a immutable variable. We are trying to do something. We create an RGB struct. We pass it to a getRed function that gets the value of red back. And then we try to set a new value of red. And this is not working. So the line here, that's the problem, is line 22. So here we are trying to reassign the value of RGB because we receive it as an input, and we try to create a new RGB struct and reassign the value to it. Can you speak louder, please? You can add a mute here, yeah. So that's basically the problem.
Is it even possible to be oh no, forget it. I saw something that was...
No, sure. Please make a question.
No, because I was reading something wrong. I thought the base was not U8, but yeah, forget about it.
No, yeah. This is clipped here, yeah. Another way we can do this is by using snapshots. So if we pass here a snapshot instead, and we define here, this receives a snapshot. This also needs to be mutable, yeah. I'm doing something wrong. Oh, here. So the getRed function now receives a snapshot, and we expect this to return a U8. And the error is saying we are not returning a U8, we are returning a snapshot of a U8. So instead of returning a snapshot here, we can dereference the snapshot, and we can add the star symbol here, and this will get the value from the snapshot. Because when we pass the snapshot to a function, we pass the actual snapshot, not the value. The way we access its values inside of a snapshot is to use the star symbol. And this should work now. OK. So quick testing talk. We already been using testing, unit testing. But let's say we wanted to test a function. The way we can do it is by adding a test macro here, saying that this function is a test function. And now we can have the assert keyword, the assert function inside of the function declaration. And this is basically the way of defining tests right now. You define a macro, and you make assertions inside of the function. Errors and errors propagation. We saw in the beginning there's an option type and there's a result type. An option is nothing more than an enum. It receives a generic type, and it has a function. It has an attribute sum or an attribute none. So this means that an option can either be something or can either be nothing. This can be used in a way, let's say we want to use a queue of elements, and we wanted to check if the queue is empty and if it has something in the first position. Instead of returning true or false, we can return an option. And an option here will say to us, OK, this also, the option can be nothing, and the queue's value is empty. There's nothing in the elements array. Or we have something here, and if you have something here, we have the value for the position 0 in this case. This is the way of using options. So let's say we have a test, we have a queue, we have 3 elements in the queue. We can use a match to make sure that if we have something in the queue, we get the value back. If we have nothing in the queue, we say, OK, the queue is empty. Same thing for results. Results are similar to options. The major difference is that instead of having a sum, we have an OK. And instead of having none with an empty type, we have an error with a specific error. If for some reason we want to fail, or if we want to specify in our program that the function or the result cannot continue the execution, we can say, okay, we have an error, and this error will make it more clear. The same function as before. This is just a wrap. We don't need to use options inside of results, and it's basically a way of returning a result from the previous results, from the previous function. The peak front, now instead of returning an option, returns a result. In the result, you can see the difference here. Option sum or result OK. Option none or result error. The difference is basically to, if I'm OK with continuing the execution, maybe I can use an option. If I want to propagate an error back to the stack call, I use a result and say, OK, there was an error that appeared. You need to handle it. You need to handle it. Be aware. And you can use it here in the peak front test, like we did before. If the peak front returns OK, we have the value. If it returns an error, we can say, OK, there was an error. I'm going to panic. I'm going to stop the execution of the function. I don't want to continue this because let's say that now that we know the function is the queue is empty. If we try to do something else in the queue, this will cause more errors. So it's better to stop it as soon as we know. Okay. So there are a lot of libraries we've been using implicitly. Not everything is implemented yet. Cairo is still a very early language. And we have been using arrays, dictionaries, assertions. There's basically, I can show you very quickly here. If you go to the Cairo, we have a core view, and we have all of these standard libraries that we can use in the language. We have arrays, boxes, dictionaries, integers, options, results. Everything is defined in those libraries. We also been looking at to organize modules. So if we go back here, you can see I have a weave.cairo file here, and this defines multiple modules. This is very similar to Rust, where we define the names of the modules that we want to load. And if we go look here in the exercise 1 as a module, so module exercise 1. Ownership is also a module, so we have a module ownership, and we can define the ownership here to have further down modules. This is basically a way of structuring your code into more compact code bits or code modules, in the sense. Yeah, basically everything that I've been explaining. Yeah, things to keep in mind. Memory is immutable by default, so you can treat memory as a read and write memory. It's more like a queue, where you put something in the head and remove from the bottom or whatever you want. So memory, in-place memory operations are a bit intensive. If we want to modify the position tree of an array, this will mean that we need to copy the entire array to a new memory slot, change the value, and then keep the clone after. So you need to rebuild the entire array every time you make a change. So if you want to read and write memory, probably better to use a dictionary, where you can define specific numbers, specific keys to specific values. Just how to debug, there's a trait to debug. You can call print. This will print to the console. You can use it on fields, booleans, functions, basically standard stuff. If you want to learn more about Cairo 1 explicitly, I recommend the Starklinks Cairo 1 repo. This is basically interactive exercises that you can do to drill down these topics that we've been discussing so far. So if you want to learn more, I recommend going to the Starklinks Cairo. Cairo, there's also a library with data structures and implementations and algorithms using Cairo 1. It's also nice to explore. If you want to have some templates, Cairo templates is also cool. Awesome Cairo is a collection of libraries and tools that you might want to check out. And also check the compiler, because all the information is in the compiler. And this is also Cairo. Where's the Starknet? Starknet is coming. But basically, the way to define Starknet is just you define a contract, and you can use a custom macro to define a contract, and you can use a custom module to define your contracts. So a Starknet contract is basically a Cairo module. But we'll see this after the coffee break. Okay, so let's now talk about Starknet. We've been looking into Cairo a lot longer. Let's first look into Starknet. So let's start with what is Starknet. Starknet is a validity rollup, also known as a ZK rollup. And basically this means that instead of doing multiple transactions in layer 1, we can do it in layer 2, and then those transactions will be rolled up into layer 1. This is basically, instead of having a lot of transactions in Ethereum, we will do the transactions in layer 2. There's a way of rolling up the transactions and generating a cryptographic proof, and that proof will then be sent to layer 1, and the state update will ensure that the transactions happened in the layer 2. The main purpose of Starknet is simply to improve Ethereum scalability, is to make Ethereum faster, more cheaper. That's basically it. So you can think of it of how easy it is to verify that a Sudoku is correctly solved, right? If you imagine a Sudoku grid, you can quickly check, oh, this is correctly solved, or there's a problem here somewhere. But a Sudoku is very difficult to calculate the solution, because you need to make sure every single square follows a certain types of constraints. All those constraints are true. So very difficult to calculate. And there's basically a question, which is, how can we show people that we have a solution for a Sudoku without showing them the solution? Because we want to, let's say we are competing to solve a Sudoku. I say I have a solution, and I can prove to you that I have a solution, but I don't want to show you my solution, because that way you will also know the solution. So this is why ZK proofs are very useful, because with a ZK proof, you can do just that. You can create a proof that you know a certain information, and you can show to a third party that you are in possession of a solution, and you know it. So basically, Starknet uses ZK proofs in a way to generate these Sudoku verification proofs to replace Ethereum computation. Instead of having Ethereum compute a lot of transactions, we can do a smaller, cheaper verification of a ZK proof using Starks that was computed off-chain, and that way we can increase the scalability. So, smart contract in Starknet. This is it. This is basically the simplest contract you can have in Starknet. You define a contract attribute, you specify a module, you give it a name, that's it, you have a contract. This contract doesn't do anything, but it's a valid contract. If you want to do more things with it, here's how we can do it. We have a struct, and this struct is special in Starknet, called storage. And the struct storage is basically the same thing as a state in Ethereum. When we do smart contracts in Ethereum, we have a state definitions. The storage struct in Starknet, basically the same thing. We can have, in this case, we have a balance, and this will keep track of a balance, but we can also have maps. We can also have a lot of information here in this struct. And this is Cairo, so you know how to read this already. This is basically a struct that we've been seeing so far. Then we have another attribute here called external. And this is basically to inform that the next function is an external function and can be called from the outside of the contract. So this is how you define functions that can be called by users, in essence. The same thing for a view function. The difference between an external and a view function is the external function usually updates the state, and the view function simply retrieves a value or performs a computation but doesn't change the state of the contract. So an external function here is writing a new balance to the storage, while a view function is simply reading it and is not affecting the state. Then we have events, and we can define an event by using the event attribute, and we specify a function, and this function is empty. This is the way to define events. We define a function, the name of the function, and this will be the name of the event, and the parameters that we want to pass to that event. So in this case, we have two parameters. We have the from, which is a contract address, and we have the message, which is a felt. This is wrong. It should be a felt 252. These slides were made before the change happened, where felts start to become felt 252s. This should be a felt 252. But yeah, then we can use an event this way, simply calling a function like we've been doing so far. Yeah.
Is that get call or address function the same as message sender in solution?
Yeah, I was going to say. The way to know who calls your function, you can use the get call address, and this function you have to import it from the Starknet crate or Starknet module. And when you do it, when you do this, you have access to the caller of the function, and then you can say, okay, the greet for this specific address, and receives a message. Yeah, I had arrows pointing to things. Okay. If we want to call another contract from our own contract, you need to define an ABI, and we also have an attribute for an ABI. And this is basically the ABI of a contract that we are wanting to call. And it's a contract that has a function named hello and returns a value. And the way we can call it is by using a dispatcher. And these are traits that are implemented automatically by the Starknet module, kind of like the derived copy thing that we saw before. And when we call this hello function here in our own contract, in the hello Starknet, if we pass the address of the contract that we want to call, we can instantiate the dispatcher with that address, and we can call that hello function. This is the way to call external functions, external contracts in our own contract. Okay. So this is basically the architecture that Starknet currently has. There are transactions happening in layer 2. Those transactions get picked up by a sequencer. The sequencer will order the transactions in some order and will create blocks. Those blocks are sent to a prover. The prover generates a cryptographic proof that those blocks are true, they're not falsified, and then the proof is being sent to a verifier contract in Ethereum. This bottom section here is Ethereum. And at the same time, the sequencer also sends some information to the Starknet core contract saying that those transactions happened and we have a proof to verify it. So this is basically how the architecture looks at the moment. Any questions? No? What's Starknet core? Starknet core is a special contract in Ethereum that receives messages from the sequencer and basically deals with the state update that happens when the new information is updated, is sent to Ethereum. Okay, now we have wallets. Like we have MetaMask in Ethereum, we also need to have a wallet to interact with Starknet. There are basically two at the moment, Argentex and Bravos. And an account is a way to represent the user on chain and the way to interact with the blockchain. In Ethereum, your wallet is your account. There's no separation there. You can think of it as the same thing. But in Starknet, there's already account abstraction where you have the wallet be separate from the account. So this means that your account is not your signer. The account is not, the wallet that you sign needs to call a function, needs to call a contract to get the signer to approve a transaction. Because in Starknet, we have account contracts, and those account contracts are responsible for signing the transactions. And they are basically specialized smart contracts that can do specialized things. And since they are smart contracts, you can deploy your own smart contract. You can deploy your own wallet contract in Starknet and make it do custom things. Things like 2FA, social recovery mechanisms, they are present with account abstraction in Starknet already. This is the part where things are going to break. I have here a contract that I wrote. It's called, you can see it already, yeah. I have a Starknet Workshop Lisbon contract here. I'm defining a storage struct. I have a balance here, it's a number. I have a couple of events, balance increased and balance decreased. Receive a balance, nothing special. I have two functions, increase and decrease balance. They're basically reading the current state and updating or subtracting. adding or subtracting, and then writing the new balance to the store, to the state. We also have a view function that basically gets us back the value that's in the store. So,
I have a question.
yeah.
Doesn't Cairo generate automatic getters like in Solidity? You have to define them yourself?
You have to define them yourself, yeah. There's this read and the write here, but this is for storage state variables. So the write and the read get automatically generated for you, so you can call them directly. If you notice, I'm not defining balance anywhere else other than here. So the storage struct has some magic behind it and can give us back a write and a read function. But yeah, you need to, if you want to access it from the outside, you need to define the function and read it from outside. Okay, what I was going to do is, I'm going to show you how to compile this, and for this, we call Starknet compile, and we pass the name of the contract here, and we need to pass the output that we want. And this compiles to a JSON file, and this is the beginning. In the beginning, I talk about Sierra, which is that intermediate representation. The Cairo contract will be compiled into Sierra. So if I do this to a JSON file, now it's compiled. There's no errors. Everything's OK. If we look here, we can see the output of the compilation. You don't need to worry about this. Just so you are that this is what's being compiled to. Basically, a series of instructions and arrays and addresses, and all the way on the beginning, on the end, you also have the ABI of your contract. So you can, the same way you have in Solidity, you have the ABI. You also have the ABI here, and you know that this is a function that decreases the bounds, receives an amount, which is a felt. It's an external function, or it's a view function. There's these events. This is how you can get the ABI. OK. Now, if we want to deploy this, there are two steps that we need to do. First, we need to do Starknet declare. It's not showing. Why is it not showing? Here. First, we need to do this. Starknet declare contract, and we pass in the result of the compilation outputs that we declared before, that we compiled before. So this is the first step to deploy a contract. You have to declare it, and then you can deploy it. Since I already did it, this is going to fail, and I can show you how it's going to fail. But the reason is there can only be, I forgot to activate the environment. There can only be one instance of a contract deployed in Starknet. So if I deploy the same code exactly twice, Starknet will say, no, that code was already declared. What you can do is make a new deployment, but you can't declare it twice because that exact bytecode is already present in the network. And this is, yeah. Making a request, so and then we have a status 500, and we have a message saying class already declared, because this was declared already. If I go here, my presentation, I have this tab open. Yeah. So this was the, by the way, I'm not sure if you're familiar, but this is a StarkScan Explorer. This is basically the equivalent to EtherScan in Starknet. You can search for transactions, contracts, wallets, whatever. I have the address here of the contract. And in the read-write tab, I can call the function that I was declaring in my contract. I can do a get balance. Right now is 0. But if I go to the right, and if I connect my wallet, I can do an increase amount. And let's say I do 42. It's going to open Argent. It's going to ask me to confirm. It's going to give me a transaction hash. And here we have the status of the transaction. Right now it's in the received state. And this means that Starknet already received our transaction, but it's still being processed. So it's not yet accepted into the chain. is not yet accepted to the sequencer. The next step will be pending, and the next step will be accepted on L2, and finally accepted on L1. So just so you are aware, these are the steps that a transaction goes through in Starknet. The transaction exists. The transaction is waiting to be accepted by the sequencer. The transaction was accepted by the sequencer when it's going on accepted on L2. And only after accepted on L1 is when we have the state update being sent to Ethereum. We don't need to wait until it's being accepted on L1. We can assume that after it was accepted on L2, the rollup will succeed, so the information should be there. This is going to take a bit, but let me refresh. Yeah. While this is happening, we know that the contract failed because it was already declared. But if it wasn't, if it's the first time I'm declaring that contract, we get an output like this. We have a contract class hash, and we have a transaction hash. Transaction hash is just simply the transaction hash of my transaction. The contract class hash is what you need to make a deployment. So this is what identifies a contract as unique in the chain. This is an hash that contains the bytecode. And you make a deployment using this class hash. And the way you do a deployment is simply calling Starknet, deploy, you pass in class hash, and the name, the value of the class hash. So, this will be how you make the deployment of my contract. Since I already have the contract deployed, I'm not going to do it again, but yeah.
Don't you need a provider like in Fury to do the deployment?
You don't, because you are automatically connected to the RPC from Starknet. I can show the documentation, but if you go to the documentation of Starknet, they explain how you can create an account and how you can fund your account. If we go here, deploying your smart contracts, you can create an account. This will create your account. You need to send funds to it. You can use a faucet or you can use Stargate to migrate the funds there. You can deploy your account, and that's it. Then you can start making contract deployments and declarations. You don't need to specify, I'm using Alchemy or Infura or whatever. You interact direct with the node. Yeah, this is basically just it. This is what you need, and you will be making a deployment. Let's check the status here. Yeah, it passed to pending already, so we know that things are moving. If we go back here and we read from the balance, it should still be 0. Oh, no, it's already updated. Now our balance is 42. So StarkScan is basically one way you can interact with your contracts, and you can have all the functions that you can read here, all the functions you can write here. Another way is to making calls directly from the CLI, and I can have this here. If I do this, Starknet call, and there's a difference between call and invoke. Call usually is for view functions. Invoke is for functions that change the state. You do Starknet call, the name of the function that you want to call, the address of the address, contract that you want to call, and this should return 42 as well. If we wanted to update the state, I have my notes here, and let's say I want to decrease the balance now. I do a Starknet invoke because I'm passing in an extra input to the function because the function receives some inputs, and I do a Starknet invoke. I call this. This gets me back the address of the contract I just made my transaction to, and the transaction hash, where I can check the state and see if the transaction was accepted. When I forgot to do this. Yeah, transaction was received. When it's accepted, the state should change. Yeah, I think it's pretty much it. You have a contract here. Where is the contract? Simple contract, some events, some increase functions, some view functions, make a deployment, interact with it. You can interact with the CLI or through the testnet. There's also ways to interact with via frontend. Yeah, that's pretty much it. Yeah, you can also see the events here. If you go to the transactions, it's not here. Events, yeah. You have a tab here for events on a transaction, and you can see that the event balance increased, was emitted, and also transaction executed and transferred more events that Starknet does for you. But basically, your event was emitted here. This is a way also checking. And I think you can also check all the events that were emitted for your contract since the beginning. I deployed this morning, so I made some tests just to make sure it was working. I can see here I have balance increased 6 hours ago, 5 hours ago, and now my balance increased 8 minutes ago. Not this, here. Okay, so there's also a way to make Starknet talk with Ethereum and vice versa. And one of the things that we can do with it is simply bridging funds from Ethereum or Starknet, either way. And for it, we can use Starkgate, which is a bridge that was developed by Starkware, where you can send some Ethereum funds and then receive them on Starknet, or you can send from Starknet and also receive them in Ethereum. Because contracts on L2 can interact asynchronously with contracts on L1, and the same thing happens on the reverse. Very quick diagram on how this works. On L2, on your smart contract, you can send a special message to L1. There's a function called send message to L1, and this function will send a message to Starknet. And when the state update happens, when the rollup happens, the Starknet core contract will consume that message, and then your contract on L1 also needs to call a consume message to get the value that you sent from L2. So when you are sending things from L2 to L1, you need to make a transaction in L2. You need to wait until the state update happens, and then you need to also call your contract in L1 to consume the message. So usually there's always a pair of contracts between L2 and L1. So you can define your interaction message system here. You can define selectors or function attribute names that you control on both sides so that you can consume specific messages. Is this clear, more or less? On the reverse, you can have contracts in L1 sending messages to L2. There's also send message to L2 contract function from the Starknet core contract that will send a message to the Starknet ecosystem. And on your L2 contract, you can define some handler functions that will basically handle the function when the sequencer triggers the transaction. So basically, the information that is getting sent to Starknet is being picked up by the sequencer. The sequencer sees there's a message to be triggered to that specific contract and will trigger a transaction to it. And that's it. We are done. So quick recap. We saw Cairo 1. We saw how to develop smart contracts in Starknet, what we call external contracts, define events, external functions, view functions. We talked briefly about account abstraction, and now we can do L1 to L2 messaging passing from one side to the other. Any questions?
Yeah. Why isn't the Starknet token listed on CoinMarketCap?
I think that's not a question for this workshop because I don't know the answer. And I think there's no smart Starknet token native because Starknet uses Ethereum.
But didn't you, in a previous slide,
This?
one talks about the Starknet token.
Token bridge. This is not Starknet token. This is Stargate is the Ethereum Starknet token bridge. So Stargate is a token bridge between Starknet and Ethereum. But what you do here is Ethereum from one side to the other.
So what is the native currency of the Starknet blockchain?
Is Ethereum? Is Ethereum? Yeah, is it Ether? I can show you. I think we still have time. Let me check. Yeah. I can show you how we can do a bridge between Ethereum and Starknet, or how we can send funds from one side to the other. Let me first make sure I'm sending go early. Okay, so see here two buttons. I have connect Ethereum wallet and connect Starknet wallets. I can connect Ethereum wallet with MetaMask, connect Starknet wallet with Argent, and they're connected. Now, let's say I want to send money from Ethereum to Starknet. I'm sending ETH. I'm sending normal Ethereum. So if I do here 001, I can simply say, OK, I want to transfer this. This is going to ask me to confirm my transaction on MetaMask first. And OK, it should be fine. And it's being transferred. This transaction is going to happen, and as we saw here, what's essentially happening is this step right here. So I interacted directly with the smart contract in L1 that sent a message to L2. When the state update happens, when Ethereum sends them, or when the smart Starknet contract sends the message to Starknet, Starknet is going to pick up that message, and then is going to trigger a transaction to the Starknet core contract, to the Starknet core contract, and then that will be handled on my side. So this is probably, yeah, transaction was sent. You can see here on Etherscan, and you can also see on StarkScan. And if we do this way, this is still processing, but yeah, now it's a success. There are 2 blocks of information already, so we know the transaction was accepted on Ethereum. Now it's just a question of being accepted on Starknet. And you can see here already that it was sent from L1 to L2 to my address, and all the information is here. If we want to do the reverse, we can also do it. They call it withdraw, simply because we are taking money from L2 and sending it to L1. If I do 0.01 again, I can do a transfer. This is going to ask me to confirm on Argent because I'm initializing a transaction on L2. I confirm, and this is going to happen the same way. This is basically the other flow that we saw here, where I'm interacting with a smart contract on L2. This is sending a message to Starknet. When the state update happens, and the state update happens roughly every 30 minutes to 1 hour to 1 hour and a half, depends on the network, then I'll have to consume the message on L1 to get the funds back. So yeah, there's no native token because Starknet uses Ethereum.
Yeah, but there will be. I think they already have some token deployed on Ethereum, and in the future, right now, as David said, everything is Ethereum, so the gas fees that you are paying on Starknet, you are actually paying Ethereum, but in the future, it will be the Starknet token that will be used to pay the gas fees. So it's not on CoinMarketCap because it's still not official, or released the token because it's aired about it.
And just to say here, please come back in 12 hours to complete withdrawing on Ethereum, because the state update usually takes a lot longer than the reverse. Because sending information from L1 to L2 is cheap, is fast, because they simply accept a transaction in L1 and we send a message. Sending from L2 to L1, it's a bit slower because we need to compute all the proofs and make sure the ZK proofs are correct and sent to Ethereum. So that's why it's a bit slower. More questions? No? I think that's it. Thank you for coming. For the resources. I think there's basically the ones that I showed here. Basically, all throughout the slides, I have some links to documentation, specifically maybe on the next part. Yeah, I have some more links here to the Cairo book. And Cairo book is one resource that you can look to learn more about Cairo. Basically going over to how we can program Cairo, basically. The same thing happens for Starknet. There's also a book.starknet.io. This is still under construction, so a lot of information here will still be updated from day to day. But this also can get you a very good introduction into Starknet, and now you can make smart contracts with it. And more resources. I think the Stark Links Cairo 1 is a great resource for you to learn because it asks you to complete exercises, and you can I'm gonna show here. I think I have it already. Yeah, I have it here already. So basically what we do is something like this. And this is going to ask you to run an exercise. And in this case, it's exercise 1, intro 1. Basically a simple exercise to explain how the things work. In this case, you're just doing this. But if you do intro 2, the exercise won't compile. Can you make it compile? So it's a lot of these small iterative steps that will teach you a lot about Cairo. And there are a lot of information on a lot of exercises. If you look here, we have things about arrays, enums, functions, info, if, loops, move semantics that we see, the ownership things, structs, traits, variables. So I think this is a great resource if you want to learn more about Cairo. Also, the documentation for both Starknet and Cairo 1 is also very good. I think, yeah, that's it. Am I forgetting something? I don't think so. I think that's it. Oh, yeah, and throughout the slides, I also have links to things. But for example, here, I have a link to the Cairo repo, where this contract was inspired from. And I think here is also a link to the Starknet. So in general, the documentation is a very good place. Also, you can also join the Discord for Starknet. There are a lot of people there that will help you with your questions. I think that's it. Thank you for your time. We're done.